A good review sheet has more on it than is on the test, but since we have such limited time, we're going to kind of narrow our focus a little bit. So this is problem 1A and 1B. These are on your exam, okay? If I do it today, it's on your exam. Got that? So these are things you need to be able to do. So I will say that the problem on the exam isn't quite this complicated, but it's these same concepts. So what do I do to simplify this? Lots of stuff. What do you think to do?
Would it, like, get the stuff on like the top and bottom, like flip it if it's negative?
Okay, so take care of the negative exponents, and maybe since you have x's and y's and z's, maybe just start combining those things. So I got 4 and a 9. Not doing anything with that. What happens to these 3? What happens to these guys right here? Oh my goodness, we got some review to do. They come down, because that's how you handle a negative exponent. So how many are down here to start with? How many x's are down here? 1. And I'm bringing down 3 more, so that's going to give me a total of 4 on the bottom. All right, let's look at our y's. Nobody's moving. Everything's positive, nobody's moving. How many y's are on the top? 5. How many y's are on the bottom? 1. They're going to cancel. When they're on top of each other, they cancel. So what happens? Going to be how many? 4. And where are they going to be? On the top. Because that's y, 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 y. Those are going to cancel, and I'm left with 4 on the top. Now, what about the z's? What's happening with those? These are going to have to come down because they're negative, and when they have a negative exponent, they move. So if they're on the top, they come down. If they're on the bottom, they go to the top. So how many are down there already, z-wise? 2. Bringing down 4 more is going to make z to the 6th on the bottom. And I haven't done anything with that 1/2 yet. So Scout suggested, I think really wisely, that we do just combining in here first, get this cleaned up. Now, there's no more combining to do, so now we're going to take everything to the 1/2 power. Now, the exponent part is easy. What do I do with these exponents? Well, I multiply. This is a multiply situation. So that's going to be y to the 2nd. That's going to be x to the 2nd. And that's going to be z to the 3rd. Because I'm multiplying exponents. Now, that's not how it works with numbers. That's how it works with the exponents. For the numbers, you have to remember that 4 to the 1/2 means the square root of 4. A fractional exponent is a radical. So this is the square root of 4, which is 2. And then 9 to the 1/2 would mean the square root of 9, which is 3. So our answer is right there. That's our answer. Now, let's look at our formula sheet. There's a couple things on here. Tangent is sine over cosine, and cosecant is 1 over sine. So those are helpful little things. All right, so here we go. I think it's wise to leave your sines alone, sines and cosines. So I'm going to just make that sine over 1. Then what am I going to change my tangent into? Sine over cosine. What am I going to change my cosecant into? But since it's squared, it'll be 1 over sine squared, because it's squared. Cotangent. Now that's not up here, but if I have told you that tangent is sine over cosine, I mean, you ought to know that what's cotangent then? Cosine over sine, because they're reciprocals. I told you that cosecant is 1 over sine, which means secant is what? 1 over cosine. Come on, you gotta think a little bit, right? You need to know a couple of things here. All right, now, once you got it all written out in fractions, you can start canceling anything that will cancel. So these 2 signs will cancel with those 2 signs. These 2 cosines will cancel with those 2 cosines. And all that's left on the top is a 1. And all that's left on the bottom is a sine squared. And that is perfectly fine for your answer. Alright, now we're going to skip down to 2a, which says sine 240. We did one of these the other day. Who remembers how we started? Yes, we draw 240. So our labels and standard position are these. So 240 is going to be over here. This is 240 degrees. What do we do after we figure out where the angle is? Make a triangle. So the triangle always goes straight up or down to the x-axis, like that. Then we got to figure out how big that angle is. And it isn't hard if you're thinking. Look at it. It's 60. How do we know it's 60? Because that's 180. And this is 240. And the distance in between 180 and 240 is 60. Now, on the reference sheet is a 30, 60, 90 triangle. So across from the 60 is root 3. Across from the 30 is 1, the hypotenuse is 2. What you have to remember or pay attention to on your own is something in there is negative. Because unless you're in quadrant 1, something is negative. So what's negative in this problem?
1
The 1 and the root 3 are both negative. Is the hypotenuse ever negative? No, but the 1 and the root 3 are. All right, and then we got to remember, look right here, sine is opposite over hypotenuse. So here's your angle. What's the opposite side? And the hypotenuse? So the answer is negative root 3 over 2. All right, next. Problem number 4a says solve this equation. Easy. One quick step takes 15 seconds. Anybody remember how to do it? Loop-de-loo. Yep, this is a loop-de-loo. So 5 to the negative second equals x. We already talked about this. What does a negative exponent mean? No, fractional exponents are radicals. Negative exponents move. So this is 1 over 5 squared, which is 1 over 25. Now, what's going to happen on the test is if you stop here, you get half credit. But you got to simplify everything. This is not simplified. 1 over 5 squared, 1/25. All right, next D, problem D in number 4. Nine to the 5x plus 1 equals 27 to the 2x minus 3. All right, Caden, we did this morning. Tell me what's going on here. What's special about 9 and 27?
They go into each other?
Well, they go into each other, but it's more than that. That doesn't really help me do the problem. Josh?
They're both 3 squares.
They're both powers of 3. 9 is 3 squared. And and 27 is 3 cubed. Notice this is not a calculator problem. So you have to be able to do this if it's not a calculator problem. Now, it might not be 9 and 27, it might be 16 and 8, or 25 and 125. If it's no calculator, you have got to be able to rewrite both numbers as the same number to a different power. So this is 3 squared, this is 3 cubed. Now, anybody remember what happens once you do that? Well, this says 3 to the 10x plus 2, this is a multiply, distributive, equals 3 to the 6x minus 9. Now think about that. If 3 to this power is the same as 3 to this power, what makes sense? The powers have to be equal, yeah. So 10x plus 2 has to equal 6x minus 9. So 4x equals negative 11. It looks like x is negative 11 over 4 if I just solve that equation. Now the one right next to it is a calculator problem. So get your calculators out. It has a star next to it. Your exam is 2 pages. 1 page front and back, calculator. 1 page front and back, no calculator. It's like a regular test. So this is going to be on the calculator page. Notice that's a 5 and that's an 8. Can we do this little trick with a 5 and an 8? No, that's why it's a calculator problem. Okay? So, anybody remember how we do that? We take the logarithm of both sides,
Does that bring the 3x?
and then the power comes out in front. That's the magic of it. And your job is to get x by itself. So what are we going to do to get x by itself? We want to know what x equals. What?
Divide by log.
We were going to divide by log 5. So that's a calculator thing. So log 8 divided by log 5. If your calculator is one that requires you to put in parentheses, when you hit log 8, make sure you close the parentheses before you hit divided by log 5. Okay, so I got 1.292, a whole bunch of stuff there. But if I only divided by log 5, that leaves me with 3x equals. So now I have to take that decimal and divide by 3. So the answer is 0.4307 if I round off to the nearest hundredth. Or thousandth, I guess, 10,000. I don't know what, I can't remember what the rounding instructions are on the exam. All right, so now we're back to problem 6, which is not a calculator problem. This is not a calculator problem. It says how many degrees is this? Do you remember how to do that? This is so easy.
That equals 180.
What's Josh? Or Jacob?
Radians squared, is that what it was?
No. Q?
Doesn't the pi sign equal 180?
Yeah, pi's 180. All we do is put a 180 in here. So this is 3 times 180 divided by 5. We just, pi radians is 180 degrees. So this is 3/5 pi, so it's just 3/5 times 180. Now that's a no calculator problem, so you can do it however you want in terms of your arithmetic. I usually do the division first. You don't have to, but this is my personal way of doing it. So that goes in 36 times, and then I take 3 times 36, and I get 108 degrees. So it's 108 degrees. All right, and then, let's see, next is 7. Oh my gosh, if anybody misses this, I don't even know what to say. What do we need to do in a problem like this?
Substitution.
Substitute or eliminate. Now, we also learned some other things like Kramer's rule and all that. If you want to do it, fine, but definitely you know how to substitute and eliminate. Do whatever works for you. I am an eliminator, so I am going to eliminate. So I am going to multiply the top row by -4. And add it to the bottom row. So I chose to multiply the top row by -4, and that's going to give me 19y equals 19. Well, that worked out nicely. So y is 1. And then what do?
Plug it in.
Plug it back in. So anywhere I want, so I'll put it in the top here. X minus 3 times 1, remember that's y, equals 2. So x minus 3 equals 2, and it looks like x equals 5. So my answer is 5, 1. Remember, your answer is an ordered pair, and ordered pairs are always x, y. All right, next we have 9A and B. They are both calculator problems, and they are both finding the area of a triangle. Okay, how do we do that? Josh?
You add them all up and divide by 2.
So for this one, we're going to use Hero's formula, which is that big radical. And again, my job today is not to teach you this. I already tried to do that before. This is all in your notes. Practice tests. You go back and find it if you need to review. Hero's formula says find the semi-perimeter. So first we find the perimeter. So like he said, we add them all up. So adding them all up gives me 34. Check my arithmetic, 34. This is a calculator problem. So, and then we take half of that. The semi-perimeter then is 17. So 17 is the first number under the radical. Then there are 3 more.
It's each of those numbers.
17 minus
Minus
each of those sides. Yep. So it's 17 minus 10, 17 minus 11, 17 minus 13. And then we just multiply them all together and take the square root. And the answer is 53.44. If there are units there. Now, that's how we're going to find the area if we know all 3 sides. We don't know that over here, so we have another strategy over here.
Like,
Oh my gosh, look on our reference sheet. What's it say right up there? See that one with the square root and the S and all that? That's what we just did, right? And look right under it. It says area equals 1/2 side times sine of included angle. So area is 1/2 17 times 14 times sine 37. So that's easy. I just type it on my calculator. 1/2 oops, 1/2 times side times side times sine of included angle. And that one is 71.62. All right, now we have another calculator problem. This is number 12. And this one says find H, now not area. Know that that triangle looks a lot like this one. This was an area problem, so we did our area formula. This one is finding this side. So let's look at our sheet, see if we have a formula up there that will help us
Sine
find
A
the
over
side.
A.
What?
Sine A over A equals sine B.
Now, the law of sines is a possibility, but it won't work in this problem because, remember, to use the law of sines, you have to have a pair. Scout, remember? And I don't have a pair, because I don't have this pair, I don't have this pair, and I don't have this pair. Remember that, guys, circling those things? If you don't have that, you're not using the law of sines. And if you're not using the law of sines, then you gotta be using the law of cosines. So that's on there. Letters are different. Okay, I can't use the right letters, and every problem has different letters. You gotta recognize the pattern. So h squared equals 17 squared plus 18 squared minus 2 times 17 times 18 times the cosine of 42. You have to recognize this is going to be a law of cosines problem. Then you have to look at your sheet. It's the second thing from the top. That's the law of cosines. The angle is 42. So this is the setup for that. I'm going to type all that in on my calculator. And I'm going to square root it. So H turns out to be 12.58. Oh, I never checked to make sure I was in degrees, yeah. All these problems are in degrees, so we want to make sure that our calculator's set right. And mine is, so I'm good. All right, next we got 13B. 13B says this. Okay, so first we have to take care of that. See that minus right there? I wrote that down. So I'm covering that up now because it's not going to confuse me. I already wrote it down. Down here I'm subtracting. Now, what am I subtracting? 2 times all that. So that's going to be -4, 2, -14, 6. So this is a subtraction problem. It's this minus this. So 2 times that is right there. To subtract, I just do entry by entry. So what's 5 minus -4? 9. What's 6 minus 2? 0 minus -14. And -1 minus 6. And there's your answer. Now, that is a no calculator problem. You are going to have to do some very basic arithmetic. You are capable of adding and subtracting little numbers like that, so we're not panicked about it. Next one is C, which says we are multiplying these two things together. All right? So remember how this works? This is a 2 by 2, 2 rows, 2 columns. This is a 2 by 2, 2 rows, 2 columns. These match. So we're good to go. And this tells me my answer. So my answer is going to be another 2 by 2. 2 rows, 2 columns. Remember how to find that number? Well, we need to multiply the first row times the first column. So the first row is 5, 6. The first column is -2, -7. So I multiply each pair and add them together. So that's -10 and -42. -52 right here. How do I do this one?
The first row.
First row, so still the 5 and the 6, but now the second column, so 1 and 3. So you multiply each pair and then add them up. So what is that, 23? Now we're down here in the second row. So we're using 0 and -1. We'll do times -2 and -7. Then we'll do our 0 and -1 times 1 and 3. So we take the row numbers times the column numbers. Okay, so here we go. 0 plus 7 and 0 minus 3. So that right there is the answer. So we gotta be able to add and subtract, we gotta be able to multiply our matrices. All right, 14, I gotta rewrite the problem again. Your problem will just look like this. That's what your problem looks like. The rest of it's not there. And all you have to find is amplitude and period. But we already talked about this the other day. Amplitude. Look at that equation. You can tell me what the amplitude is. The amplitude is 3. Guys, this number right here is an amplitude. I don't know what else to do. You have to remember that. This is a cosine curve. It goes up and down 3. That's what that first number out there means. That's your amplitude. Now, the normal labels for the cosine, and you don't have to graph it. I'm graphing it so you see that, hopefully jogs your memory. You don't have to graph it. But if I were graphing it, the normal labels would be 90, 180, 270, 360. They have been changed by this number. What does that number do?
Multiplies by 2.
It divides by a half. All of these are divided by a half. That number divides. But dividing by a half is the same as multiplying by 2/1. So that last label was originally 360, but now it's been changed to 720, and that is your period. A 5-card hand is dealt from a standard deck. What's the probability, fraction, that you will get no aces? What's the denominator? It's a 5-card hand from a standard deck. What's the denominator?
52C.
5. It's a 5-card hand, so 52C5 is your denominator. Now, no aces. So if we take all the aces out of the deck, we don't want any of them. We don't want to take them out, set them over here.
48C5.
48C5. you know how to type that number into your calculator, and you know how to get a decimal will come out of that. In how many ways, this is 18, in how many ways can I select a committee of 4 from my class of 10? So there's 10 kids, and I'm picking 4. Is it gonna be 10 P4 or 10 C4?
C. I mean C.
Gotta be a C. If I'm picking a committee, guys, does the order matter?
No.
No. So whatever that is, and it's not over anything, it's just 10C4. It's only over when it's a probability. This just says how many ways can I do it, that would be 10C4. Now, 19 says, how many ways can you choose a classmate to serve as the desk sprayer and another to serve as the paper towel distributor if there are 21 students in class?
21P.
That's 21P2. Because why?
Because the order.
They have different jobs. Right? They have different jobs. If I said I'm gonna pick 2 kids to hand out suckers, then it's 21P2. I mean 21C2, if they're all handing out suckers. But if one's handing out paper towels and one handing out something else, then it's P. Order matters. 20. Find the 4th term of this expansion. Now, for this problem, you are going to need Pascal's Triangle, which isn't on your sheet, so you're going to need to know how to build Pascal's Triangle. And you should probably practice building that yourself. And I promise it's not, you're not going to have to go like to the 50th row or something. It's going to be like here. And why did I build it to the 5th row? This is 1, 2, 3, 4, 5. Why did I build it to the 5th row? Because it's to the 5th power. Now, here's a whole bunch of terms. This, if I were writing out the whole thing, which you are not, on the exam, you are not going to write out the whole expansion. These would be the numbers you would use if you were doing it. But we only want the 4th one. 1, 2, 3, 4. We need the 10. Next to the 10 is a 3x and a y, because those are the 2 parts of my problem. Okay? Now, the only thing missing, this is the answer, except I need exponents. So I remember that if I did multiply it all out, the 3x right here would be to the 5th, and then it would be to the 4th, and then the 3rd, and then the 2nd. So there's no magic. I counted 5, 4, 3, 2. And then I remember that if that's a 2, this one's got to be a 3, because they have to add up to 5. Now, this is a 10. This is a 9x squared, because you're squaring that whole thing, so it's 9x squared, and that's a y cubed. So my final answer is 90x squared y cubed. So if you want full credit for the question, that's what you have in the answer blank. All multiplied together. 22. 48 students on retreat. Each of them likes to pray or sing or both. 35 pray, 20 sing. How many only like to pray? What's going to be our strategy for problem 22? Venn diagram. So here's my Venn diagram. I got 48 kids. Everybody's praying or singing. everybody. So there's nobody out here. Everybody is in a circle. 35 are in the P circle. 20 are in the S circle. How many like to only pray?
7.
Well, I gotta figure this out. How many kids voted here? 35 like to pray, 20 like to sing. How many is that? 55. But there's only 48 kids. So that means there's some that are in both circles. So 55 minus 48, there's 7 kids in both circles. Now who are those? Those are the kids who like both. If the whole P circle is 35, then there must be 28 over here. And if the whole S circle is 20, there must be 13 over here. Now, that's everybody. I just want to know how many like to only pray. So the answer is 20. These are the only prayers. 24. Miriam did 3 homework problems on the first day of the quarter. 7 on the second day, 11 on the third day, and so on. What's happening? What's going on here? What kind of sequence is this?
Adding 4.
Adding 4, so it's arithmetic. And we are interested in the 90th term. So this is going to keep going. And we are interested in the 90th number out here. We call that a sub 90. The 90th number. It's arithmetic. And I want the 90th number, so it's that formula right there. Now, just like before, you need to know what formula does what. So that's the arithmetic formula. It says take the first term plus the common difference times n minus 1, and n is 90. So the answer is 3 plus 4 times 89, 359. That's it. That's all there is to it. All right, last page. Quickly, number 26. What's the limit in number 26A?
5 halves.
5 halves. What about 26B? No limit because 5/3 is bigger than 1. So those are our 2 kinds of limit problems. So you need to go back and make sure you know those. 25. You do not have to graph this. You're not doing, I don't think you're doing any graphing on the exam. But you do need to know about it, some things about it. So I'm going to go ahead and factor everything. And I notice I have a cancellation when I factor the top and the bottom. Now, what does that mean? Well, that means I'll have a hole in my picture, right? So if the problem says, they're just going to ask you a question about this graph. So if they said, where is the hole? You would say the hole is where x is -1, right? And then you would plug -1 in and get -3/4. Just by putting -1 in, what's left? So that might be the question. The question might be, where's the vertical asymptote? The vertical asymptote comes from the denominator, so x equals -5. Might be, what's the horizontal asymptote? Well, the horizontal asymptote's the same as the limit, so that would be y equals 1, x over x. Might be, what is the y-intercept? Well, we find a y-intercept by letting x equal 0, so that would be 0, -2/5. Guys, you already know this is already written down somewhere in your notes. You need to go back and review it. Because you're gonna have an equation on your exam that looks like that, and then you're gonna be asked a question. The other question that could be asked is, what's the x-intercept? The x-intercept comes from the numerator, so it's 2 comma 0. Remember, this part of the problem is gone. So review those rules. 100% guaranteed there's a question like everything we've done today. These are the questions. And then finally, 31 and 32. That is recent material. I mean, that's your conic sections. So you're going to look over 31 and 32. Okay? So 31, 32, and the problems we did today in class, that's the exam. So we will review again on Tuesday. And then your exam is on Wednesday.
Will there be multiple problems for each type of problem?
No, the exam does not have that many questions on it. You only have a class period. So it's like a regular